Okay, so polynomials. David, what does it say there on page 221 in the purple box? What is a polynomial? So a polynomial is a monomial or the sum of monomials. That's what we did last time as we talked about polynomials. So we've already worked with many types of expressions and equations. Today we're going to focus on special types of expressions called polynomials. Notice another definition. A polynomial is an expression that only involves numbers and variables raised to positive integer powers and the operations of addition, multiplication, and subtraction. Now, notice, for it to be a polynomial, the powers must be what? Positive powers, so no negative powers. Also, addition, subtraction, and multiplication, not division. Okay, so it's very important. Polynomials. Now you can divide one polynomial by another polynomial, but all have to have those positive powers. So let's look at our word bank real quick on this. Whoa. There we go. So a polynomial, our definition is a monomial or sum of monomials. Notice my polynomial. Is 4x squared a monomial? Yes, it is. Is 3x a monomial? Is 7 a monomial? Yeah. It is. It could be it's a one. Mono means one. Poly means basically more than one. Okay. So examples of polynomials. Now I might say an example of a polynomial. Now, according to our definition, is that an example of a polynomial? Yes, it's a monomial. So it's a type of polynomial. That's another example, 4x plus 2. So you guys want to write down your own examples in there. Write down your own example of a polynomial there. Now, what wouldn't be a polynomial? Is that a polynomial? No. It involves division. Can't have negative powers. This, so 3x cubed plus 2x to the minus first plus 2. That is not a polynomial because negative exponent. Can't have a negative exponent. So those are examples of things. So you want to write down your own example there in your word bank of what is a polynomial and what is not a polynomial. So do that right now. Take just about 10 seconds. Write down those things that are and are not polynomials. So you can see on your notes some polynomials. 5x is a polynomial. 3x squared plus 4x plus 1 is a polynomial. X cubed plus x squared plus x is a polynomial. Things that aren't polynomials. 3 divided by x. The absolute value of x minus 3. Right? Even though x minus 3 a polynomial? Yes, but the absolute value of that is not. Because remember you have that plus and minus. The absolute value can be a positive or a negative thing. So you have that. The square root of 2x plus 3. I mean, if we just had 2x plus 3, it would be a polynomial. But when I take the square root of it, because this square roots are basically to a 1/2 power. And one of our other rules for that the power has to be an integer. This could actually be written this way. 2x plus 3 to the 1/2 power. That's what square root. That's what powers of square roots. They're fractions. They're fractions. We're not there yet, but just that's why it's not a polynomial, because it's not an integer. Because notice, in that definition, is part of these definitions, it must be an integer, has to be a positive integer in the power. Negative as a fraction integer. Jeff, you had a question. You had your hand up.
It was on
Number 2. Okay. All right. So, 2x squared a term? Yes, it is. Eduardo, is x a term? Is x a term? Yes, it would be. So how many terms are in this polynomial? There are terms. So the degree of So remember, x to the first, y to the first. Those are both to the first power, so that'd be 1 plus 1 or 2, the degree of the term of that one. This So, on our word bank, I think we have degree of term. For some reason, I don't have degree of term. Oh, here we go. Degree of term bank. All the All right. 2. Which is the leading term? Which term is the lead term? Someone. Jeff. First term, right? We all agree with that? Is that the leading term? Yeah, because we have 4, 2, 1, and 0. So our negative 6x to the fourth is our leading term. And what is the degree of the polynomial? 4. 4 is our degree of the polynomial. Down here, which is that? Chris. 9x to the 6. So Chris says it's 9x to the 6, y to the 5th. Do we agree with that?
Yes.
Yeah, because remember, 6 plus 5, we have 11 here. 7, 7, and 1. So here, 9x to the 6th, y to the 5th. And remember, we add the 2, 6 plus 5. Our degree of the polynomial is 11. Any questions on how we did that? So let's talk about coefficients. We've been talking basically about the variables and their powers. Let's talk about the number. The number is the coefficient. The coefficients are the number in front of the variables or standing by themselves. Or standing by themselves. An example here. Now the terms. What are the terms in this? Well, the terms would be, 5 would be a term. We can start from this. Let's start at the end. Our terms are 2x to the 5th. The next term would be what? 4x cubed, 4x to the 3rd. Then negative 3x squared, right, because it's a minus. X. And 5. So we have 1, 2, 3, 4, 5 terms. What are Five. So the coefficients are the numbers in front. Don't forget, if it's just a letter, that's 1x. When we subtract, it's a negative. All right, these are very common mistakes. Don't get caught on that. All right, and the our word bank. So a couple of things. One, degree of polynomial. The greatest degree of terms in a polynomial. So right now, let's take about 15 of a degree of polynomial. So we're going to catch up a little bit here. We have a couple of things to put into our word bank. There, degree of polynomial. That's the one, the largest one. I might make an example like this. If I had 3x cubed plus 2x plus 1, that would be my lead 1, and my degree of polynomial would be 3. To remind myself, it's the degree of polynomial there is 3. All right? So that's one part. Questions? So everybody has their own example for degree of polynomial now? And we want to look up here to coefficient. There, the numerical factors, it's the coefficients, and the lead coefficient is that number on the leading term. On the leading term. Yes, sir. Pardon? You're going to have parts of your homework. There's a lot of little parts where you're going to be identifying each part of these things. In the homework, they're going to ask you, there's going to be a section, to identify this, identify that. They're going to take these in parts on your homework. 7 is, oh, you're right. 7 is a coefficient. Thank you. There could be just the number alone. And remember, if we want to write this all with variables, x squared, x to the 0. There, the last term would always be x to the 0. All right. Let's look up. You haven't got to those things. Okay, so some things. So our terms are these parts, leading coefficient. We have our leading term, constant term, things like that. All right. Any questions up to this point about what we've covered? Questions? Questions? So, polynomials can be named by two different ways. They can either be named linear. has one term, 2x. Dealt with that last section. Remember, there's just one term. A binomial has two terms, 2x plus 1, two terms. Doesn't matter. And it could be, and by the way, a binomial could be like this. That's still a binomial because there's two terms. Has nothing to do with the degree. Now, as far as degree, what kind of, now if we were going by the first column, what kind of we would say that was a cubic because that's the highest degree, but it's a binomial because it has two terms. A trinomial has three terms. So there's three terms. Is a trinomial. So our quadrat, when we wrote down our quadrat here is a trinomial. So let's look at our examples. First of all, by degree of polynomial, what is number one? By degree of polynomial, what type of that would be a quadratic because by number of terms, what is this? This is a so I want you guys to name the second two by their terms. By the way, so mono, bi, tri, quad, quint, things like that. Quadnomial. Things like that. So do the next two like that. By. Well, first of all, 7x. Linear, quadratic, or cubic? Linear, right? X to the first. It's linear. And it's a monomial. Monomial. This one, what degree of polynomial is it? Cubic, right? 3 is our largest one, so it's a cubic one. And for lack of a better term, you could call this a quadnomial or a... Let's go to your word bank real quick. Word bank. Notice we have binomials and trinomials. An algebraic expression that has 2 terms, algebraic expression with 3 terms. So write your own example into those boxes, your own example on your bank. And dealing with these binomials, trinomials, I mean, they do have a place, like in science. Distance equation is a quadratic. When you deal with distance, things like that, distance is a quadratic. Velocity is a linear function. Things like that. Acceleration would be a monomial on that. So that ends section 5.5. Gets us into section 5.6. So if you're following up on the book, section 5.6 starts there on page 226. Now we want to talk, usually we write polynomials. So if I have this here, degree, so it's going to be first. What's next? should all have examples for all those things we've done today. Put your examples in. We also have ascending order, the arrangement of the polynomial where the term with the smallest degree is written first, followed by the term of the next smallest, increasing fashion until you get the largest degree is written. So again, write your example of ascending order. You might also, we kind of skip this one, leading term, leading coefficient. Put your examples in for leading term and leading coefficient on that one too. Okay. What's the what? Leading term would be the one with the highest degree. So if I had like x squared plus 2x plus 3, x squared would be the leading term. And its degree, and the leading coefficient is the term. And I think they have it labeled earlier in there too. They have it labeled in the definitions on that. All right. One more slide. Polynomial. And this simply substitute in the variable and calculate. We've done this before, this way back in the beginning of the semester with other things, but I think most of ours we're dealing with linear functions and things like that. But now we're going to evaluate this. So we have 3x minus 7 for x equals 4. So I'm just going to substitute. So I get 3 times 4, right? I'm putting in 4 for x minus 7. So I get 12 minus 7, or 5. Just like that. We're just substituting in the value they give us. So you guys try number 2. Evaluate 2x squared minus 3x plus 8, where x equals 4. So everywhere where there's an x, you want to put in 4. All right, so let's look at this. So remember, everywhere there's an x, we put in 4. So I get 2 times 4 squared minus 3 times 4, 8. Anyone have a question about what I just did there? Everywhere there's an x, we put it in. So first I'm going to square. So I'm going to get 2 times 16, 4 squared, minus 12, which is 3 times 4 plus 8. 2 times 16 is 32, so I get 32 minus 12 plus 8. 32 minus 12 is 20, plus 8 is 28. So our final answer is 8. So, questions on this? Gentlemen. So the very last term polynomial. Evaluating polynomial is the same as evaluating anything else. Value of x and perform all the arithmetic to calculate the results. So right now, put in an example in for that. Put an example in your word bank for evaluating a polynomial on that. David, you have a question? Jeff?
So you have to use x?
It could be any variable. They're just using x as the example. They say x, it could be y, it could be n, it could be z, it could be a, b, whatever the variable happens to be. So, one thing I want to mention about classwork. You notice some of you got more than was some out of 11. Like I think the last classwork assignment we did was out of 11. Some of you did more than 11 problems, so you got extra credit. In other words, I look through and I think, okay, what is a reasonable amount to do in the time that I was given, and I will decide in 11. I do assign more in the classwork than I think you can actually do. So I do that on purpose. This is why I don't assign a point value to the end, because I see how you guys do on it, and then I look at how things are progressing, and then I decide what is a reasonable amount that you should have gotten done during that time period if you work diligently and things like that. And so if you did more than that value, you get it as extra credit. So some of you might got a 20 out of 11, a 30 out of 11, things like that. All right, so it behooves you to do as many as you can in this classwork period. Remember, this is practice, so you can get what's going. So when you go home, you do your homework. Gentlemen, what are we doing? Julio, we okay? We need to calm down. All right, so classwork. Now the homework's up here. Remember, division by 3. This is your homework to be done tonight. Our classwork for today. Page 224. 1 through 7. 16 through 22. 25 through 31. 43 through 46. By 3s. In other words, you start with number 1. Your next one's going to be number 4. Every time you're adding 3 to get to the next one. And page 229, 1 through 31, again, by 3s.
Is that page 22?
Page 224 and page 229. All right, wherever you are at the end of the period, you turn this in. Remember, classwork. This is your chance to come up and ask me questions and things like that. The homework is 224, 3 through 51. Divide by 3. So write 3, 6, 9, so on. And then 229, 3 through 36, divisible by 3. Again, by 3s. All right. So let's get our classwork. You guys got about 20 minutes. You guys should be able to get through a good chunk of these on that.